Dear students, today we will discuss about chemical properties of carbon compounds. We are going to study combustion reaction, oxidation reaction, addition reaction and substitution reaction of carbon compounds. The first type of chemical properties of carbon compounds is combustion. All hydrocarbons burns in air or oxygen to form carbon dioxide and water. The reaction is exothermic with evolution of large amount of heat. Hydrocarbons are mainly consists of carbon and hydrogen, and that's why when they are burnt in oxygen, the carbon dioxide and water is formed. At the same time, large amount of heat is liberated, and that heat can be used for the domestic purposes as well. In the following reaction, you will see that hydrocarbons when combines with oxygen, they give carbon dioxide, water, light is generated and also heat is given out. That means the combustion of hydrocarbons is a exothermic reaction. Let us take some examples. Number 1, when methane is burnt in air, forms carbon dioxide and water. Methane is commonly known as a Mars gas. When it is burnt in oxygen, it gives carbon dioxide, 2 molecules of water, light and heat is generated. This heat can be used for domestic purposes. The methane gas is mainly used in gobar gas. The another hydrocarbon is ethanol. When ethanol is burnt in oxygen, it forms carbon dioxide, water, light and heat. When these hydrocarbons are burnt in sufficient supply of oxygen, they burns with a blue flame and they do not produce any kind of smoke. But when the oxygen supply is limited, a yellow flame is obtained by the combustion of saturated compounds. Second chemical property of hydrocarbons is oxidation. In the last section, we have seen that in the process of combustion, all the chemical bonds in a molecule of carbon compounds break and carbon dioxide and water are formed as products. In other words, we can say that these hydrocarbons, they are completely undergoing oxidation and they forms carbon dioxide and water. Substances that give oxygen to other substances are called as oxidants or oxidizing agents. In organic chemistry or in the chemistry of hydrocarbons, the oxidizing agents like potassium permanganate or potassium dichromate, they are commonly used as a oxidizing agent. For example, to carry out the oxidation of ethanol means ethyl alcohol, the oxidizing agent is used, that is acidic potassium permanganate. When the oxidation of ethanol is carried out in the presence of acidic potassium permanganate, it get oxidized to acetic acid, that means ethanoic acid. The third chemical property of hydrocarbons is addition reaction. This reaction is similar to the combination reaction in inorganic chemistry. The reaction in which two molecules react to form a single product is known as addition reaction. The unsaturated compounds containing carbon to carbon double bond or carbon to carbon triple bond, they undergo addition reaction with hydrogen to form a saturated compound. Means we can say that the addition reaction is the characteristic property of unsaturated hydrocarbons or unsaturated compounds. Let us look at this reaction. Here this compound is a alkene because there is carbon to carbon double bond. When this alkene is combined with or reacted with hydrogen in the presence of nickel as a catalyst, the double bond breaks and the double bond is converted into carbon to carbon single bond. Means in this reaction the unsaturated hydrocarbon is converted into saturated hydrocarbon or saturated compound. Generally, this addition reaction is used for hydrogenation of vegetable oils in the presence of nickel catalyst. Vegetable oil is in a solid state, and the oil, edible oil, which contains unsaturated hydrocarbons, by passing hydrogen gas in the presence of nickel, that unsaturated hydrocarbons are converted into saturated hydrocarbons and vegetable oils are converted into we can say that dalda. Similarly, when ethene is reacted with hydrogen in the presence of nickel, it is converted into ethane. In this reaction you can see that in ethene or ethane there is a carbon to carbon double bond. When hydrogen get added to this ethene molecule, carbon to carbon double bond breaks and it is converted into carbon to carbon single bond. Means the unsaturated hydrocarbon is converted into saturated hydrocarbon. The fourth and the last chemical property of hydrocarbons is substitution reaction. Saturated hydrocarbons are less reactive than unsaturated hydrocarbons because single bonds, carbon to hydrogen bond and carbon to carbon bond, are very strong. So that's why saturated hydrocarbons are less reactive while unsaturated hydrocarbons are more reactive due to the unsaturation. In other words, we can say that the unsaturated hydrocarbons are more reactive than saturated hydrocarbons. But when the saturated hydrocarbons are reacted with chlorine under specific conditions, in this reaction chlorine atom replaces one by one all the hydrogen atoms in the saturated hydrocarbon. Chlorination of methane is a substitution reaction which gives 4 products. In this reaction you can see that there are the 4 steps. When methane, which is a saturated hydrocarbon, is reacted with chlorine under specific condition, means in the presence of sunlight, it gives methyl chloride and hydrogen chloride gas is formed. In this reaction you will find that from this methane molecule, one hydrogen atom is replaced by chlorine and there is a formation of methyl chloride. In the next step, methyl chloride, it reacts with chlorine. Again this chlorine, it removes one hydrogen atom from this methyl chloride and there is a formation of methylene chloride having formula CH2Cl2. Further, methylene chloride, it reacts with chlorine. Again this chlorine molecule, chlorine atom, it replaces one hydrogen atom from this CH2 group and it is converted into CHCl3, which is nothing but chloroform. Again when chloroform is reacted with chlorine, then the last hydrogen atom is removed by chlorine and there is a formation of carbon tetrachloride and hydrogen chloride gas is formed. The substitution reaction of saturated hydrocarbons is just like a displacement reaction.